Hello my dear students. Today we are in lecture number 38. Okay, it is lecture number 38 of chapter 3 current electricity. It's too long and lockdown my dear student, but well, we are moving with our syllabus. I am B.S. Pandey. My dear student, today we will study the very important topic. It is the cell battery. Okay, cell and battery. Student, the cell or battery, from standard 10th you have studied about the cell and battery. This is the symbol you use to draw for the cell, my dear student. The big terminal and the small terminal. The big terminal which represent the positive terminal and it is negative terminal. Practically, my dear student, we use the cell, the bigger one, it is represented by the red. Okay, so the positive represented by the red and negative represented by the black itself. Okay, whereas in your household circuit you will find the connecting wire, it is of two color. If it is black and red, then you can find if black one is neutral, that is the negative, and red one is the positive. Okay, so it is the cell. Actually, the number of cell we use to connect to form a battery. So battery is nothing but the combination of number of cell. Okay, my dear student. Here, what the use of a cell or the battery? Actually, this cell or battery used to maintain the potential difference. Okay, used to supply the potential difference or maintain the potential difference. Why potential difference is required? So the potential difference required for the flow of charge. For what we pay to the electricity board, my dear student, we pay the electricity board for the motion of electrons between our household circuit to the electricity board. Actually, we don't use electrons, we use the charge, that is, we use the energy that electron having. Okay, and the electricity board used to just charge that or to make the potential difference between us and electricity board. So here battery is the source we will study. It is the DC source. We can convert that DC source into AC also, that we have to study. This is the matter of the another or other chapters. So we focus over here about the cell and battery. Whenever we talk about the cell or battery, the first thing it is comes in our mind, the EMF, that is the electromotive force. Remember the two words you will having, the EMF, okay, represented by the small e and the particular E, and the potential difference. Don't confuse between these two. It is potential difference represented by the V and this is the EMF. Actually, my dear student, both are the same thing. Okay, this potential difference and EMF, both are the same thing. But you have to understand the very minute difference between these two. Actually, this EMF stands for EMF. It is the electromotive force. Electromotive force. Okay, my dear student. And remember, its unit is volt. It is not the force. The unit will not the Newton. It is electromagnetic EMF. It is the electromotive force, and the electromotive force actually it motivates the charge to move from one terminal to another terminal. Basically, if you want to write about the electromotive force, then you can write, my dear student, the electromotive force is not the force, but it is the amount of work done. Okay, amount of work done by charge carrier. Okay, it is the amount of work done, I am speaking actually, it is the amount of work done by charge carrier to shift itself. Okay, it is the work to shift the charge. Basically, we use study electron. Okay, shift itself from one terminal, or the electron from one terminal to another. Okay, and the electron actually move from the one terminal to another terminal and do some work, and that is the electromotive force. And electromotive force actually motivate the electron to move from one terminal to another terminal of a cell. My dear student, if suppose you are having a battery or the cell in this way, okay, and it is connected with a load resistance, any resistance, this one, and it is written V, the two terminal, it is A and B, then the potential difference will be V between A and B. We will write the potential difference as VAB. Okay, if we'll go to the market, if you will go to the market to buy a battery, now the very important question comes in your mind. If this is battery from market, suppose this one, the terminal A, and it is B, and it is written 1.5 volt. Okay, now the question, so whether this one is the EMF or potential difference. EMF and potential difference both having the same unit, it is volt, but there is a minute difference between EMF and potential difference. But I'll tell you, my dear students, this 1.5 volt is EMF, not the potential difference. So the very simple difference, or the very simple thing I'm telling you over here, later on you will be totally get cleared about the EMF and potential difference. The one thing you remember, if this cell is not connected through any circuit, if this cell is not connected through any circuit, then its potential difference actually is the EMF, or the EMF is equals to the potential difference. You can see this is not connected in circuit, and this is the open circuit. That is the open circuit, my dear students. If the circuit is open, then EMF. If the circuit is open, of course current is not flowing. Current will be how much? It is 0. So the EMF will be equal to the potential difference. Actually, you used to tell 1.5 volt, what is that? So 1.5 volt is the EMF. It's very simple. But whenever you will connect this particular cell with a circuit, suppose this is the load resistance. Okay, now the 1.5 volt. Current start moving. Now current is not equals to 0. Okay, the resistance 1.5 volt load, the potential. Now it is closed circuit. It is not open. Now it is closed. If anyone will ask, sir, whether this one is 1.5 volt, the potential difference, or the EMF, remember, my dearest, I will tell again, the EMF is 1.5 volt, but the potential difference, that is between these two terminals, here the potential difference and the EMF both are same, but here the potential difference VAB, my dear student, whether this VAV will be equals to 1.5 volt, VAB, it is the potential difference, but this is not equals to 1.5 volt. Remember. Why? Where this potential gone? Actually, here 1.5 volt written, but where this potential difference or the potential gone? If it is 1.5 volt, it should be the 1.5 volt over here also. But the answer is now potential difference is not 1.5 volt actually. So what happened to the potential difference, that we will study in very detail. Now when the circuit is closed, okay, then circuit is closed, then VAB will be smaller than EMF. It is the EMF is smaller than EMF. EMF remain constant. It is E 1.5 volt and it is constant. Remember. Why? Because this is the electromotive thing, that is the electromotive force, and it is cause due to which electron is moving, whereas potential difference is the effect which is created due to the flow of electron. Okay, remember, so the EMF remain constant. is totally like, you can study this example. You can take an example. If this is the water tank, okay, this is the water tank, then capacity of this water tank, the capacity which maintains the potential at certain height, this capacity, it is the volume, is like EMF, okay. But the level of water, here the level of water level is like potential difference, okay. As the level will goes down, remember this tank volume of tank is not going to be decreased, but here the potential, that is the level of water, is decreasing, and this water is going somewhere else, okay. If this is the tank connected with another tank, look like this one, or at the certain lowered height, if it is connected, you can take the tank of same height also, no problem. And the two tank, it is connected. As you will fill up the water start moving. Suppose water at this level, what will happen? There will be potential difference and flow of water takes place, okay. Water will flow till the labeled water of both the tank will be of same level, and that is the potential difference, but the capacity is the EMF. Remember, my students, so EMF does not changes, but the potential difference, okay, continues to be changes, and potential difference maintained. If the potential difference will be the potential of this tank and potential of this tank will be same, there will be no flow of, okay, charge, and we will not consider any electric current in that circuit. So the final conclusion I'm giving you, my dear student, if you are having a cell, then its potential difference is nothing but the EMF. If you are having a cell and the circuit is closed, current is flowing, then potential difference will be little bit lower than the EMF. Now the question, where is that potential difference or the voltage gone, sir? If it is a 1.5 volt, then where that value gone? Now, so here we will study about to understand that things, internal resistance. Internal resistance, one thing, internal drop, okay, internal drop, and terminal voltage, we know that, student, whenever any cell used to manufacture, the chemicals are used for manufacturing the cell, okay. If this is the cell used to manufacture, of course there is a chemical, or if you are using the solution, the electrolyte you will use. Now for each cell, if electron is flowing through the cell or the battery, there must be some resistance to flow the charge or the ion, and that resistance is termed as the internal resistance of the cell. Actually this is your entire cell, okay. This is the entire cell that you used to buy from the market, and this is the cell. This is the positive terminal and this is the negative terminal, my dear student. You cannot see the internal resistance, it is inside the cell or the battery. This is represented by small r, and this is the EMF. But what you got the value whenever you connect this particular cell with the circuit. You got, this is A and this is B, then you use VAB, that is the terminal voltage. You use terminal voltage, not the EMF. Remember, in circuit you use terminal voltage, and you get the terminal voltage across the terminal of cell. You never use this EMF. it was written 1.5 volt over the battery, and that is the EMF, not the potential difference. So if current flowing through this circuit, look at here again, if this is the cell of internal resistance R and it is connected, the terminal A and B, it is connected with a load resistance, say R. Okay, this is the internal resistance R and this is the EMF. If current starts flowing, remember my dear student, this is your cell. Again I am telling you, this is the cell. If current starts flowing, then what will happen? You will see the current, this current used to drop a voltage over here, this current used to drop a voltage over here, and this total voltage will be equals to the EMF. That is, the E is equals to IR plus IR. Okay, now you can see the voltage which drops over here, you never use between these two terminals. You use between the two terminals. Suppose this is load resistance, say your fan, you use in remote, you use in wall. Okay, so this particular voltage, it is, you are getting this voltage minus this voltage, this is IR. Okay, and this IR you are using, it is E minus IR. So it has been dropped down. That's why the potential difference, and this IR is not but the VAB. Okay, it is E minus IR. Now you can see by this equation easily that potential difference, that is the terminal voltage, is little bit less. How much less? It is totally depends upon the internal resistance. If internal resistance is smartly managed, very small, okay, negligible, then this will be 0. Okay, I must be there, but this will be 0, and due to this 0, this VAB equals to E. Even when current is not flowing in the circuit, you can see if current is not flowing in the circuit, this VAB will be equals to the E, as we have discussed earlier. So this is the terminal voltage, internal resistance, and the internal drop. Actually this IR is nothing but the internal drop. Why this is internal drop? Because internally inside the cell it drops and we cannot measure. Okay, and this terms you should remember, this VAB is called terminal voltage. Terminal voltage. Okay, and this IR is the internal drop, and this terminal voltage, and this is the EMF. Okay, my dear student. So this is all about this particular cell, and now we will continue this particular topic to understand the few more interesting facts about this cell. Okay, my dear student. Now we will learn how to find the internal resistance. Okay, my dear student. So finding internal resistance. Our next topic will be finding internal resistance. Okay, that small r we are going to find. A simple circuit we are drawing over here. This is the cell of internal resistance. It is connected with a load resistance. Okay, internal resistance, load resistance R, EMF, the potential we will study as the terminal voltage VAB. I don't think that now you are confused or the very tough to write all the things. This is a small IR. What is this? Suppose VAB we are representing by B, and what is that? It is the potential difference, which is also called the terminal voltage. Again I am writing terminal voltage. Okay, now this E is equals to, because this EMF, the total potential drop at two places, IR plus I into R. Could you find the current here? Yes, it is IR plus R. Okay, my dear students. Now we know that what V is equals to IR. V, that is using the Ohm's law, V equals to IR, and this V is terminal voltage. Okay, so we can write here the V is equals to I. We have calculated E over R plus R into R. So the E by V can be written as R plus R divided by R, or E by V is equals to 1 plus R by R, or R by R, it is E by V minus 1. Now we are having the internal resistance. How much it is? E by V minus 1 times the load resistance, my dear students. So this is the internal resistance. You can find the internal resistance if you are having the EMF of a cell. Okay, potential difference across the two terminal of the cell, that is the terminal voltage, and the resistance, the load resistance. Then you can find the internal resistance. Okay, so can we solve a very simple question, my dear student? Okay, so I'm giving you simple question. Kindly note down this one. The one question, write down, my dear student. A cell of EMF 12 volt. Okay, this is the example. Let a cell of EMF 12 volt connected to a resistor. Okay, connected to a resistor. It is 10 volt. EMF is given. Remember, EMF 12 volt connected to a resistor of 105 ohm. This is the load resistance, that is the high resistance, 105, through an ammeter. Oh, one ammeter is also connected, as we know that ammeter must be connected in series with the circuit. So this is our ammeter. An ammeter is connected, and the resistance of this ammeter is 5 ohm. Okay, this is a 5 ohm. Now the interesting thing, if current flowing this circuit, in this circuit, I as 1000 milliampere, okay, it is flowing through the circuit, then you have to find the internal resistance. Then R will be what? This is your question, my dear students, and this is the internal resistance. Okay, stop the video and try to solve this question. Okay, now let me solve this question. I know this is not very tough question. You can write, my dear student, here the voltage will drop at here ammeter, here the load resistance and internal resistance. So this 12 volt will be equals to the, that is E is equals to IR, I and R, this is the 5 plus 105 plus R, and I is given itself. How much? It is 0.1, that is the 1000 milliampere. Sorry, it is 100, it will be the 100 milliampere. So the 0.1, and it is 110 plus R, it is 12. So the 110 plus R, it is 120, 12 by 0.1. So the R is 120 minus 110. Data was given so that you can solve this question easily, and the 10 ohm. Okay, in this way you can solve the question. Not very tough question. Okay, write one homework. There are 5 to 6 questions I have given in assignment for this cell. Okay, for level 1 or 0 level, you can say, for build up your confidence. Now write down a homework. A battery of EMF E and internal resistance R. Okay, battery of EMF E and internal resistance R gives a current of 0.5 ampere. Okay, it gives a current of 0.5 ampere with an external resistance of 12 ohm. External resistance of how much? 12 ohm. And a current of, this is the first statement. Now, and a current of 0.25 ampere, 0.2 with external resistance of 25 ohm. 25. Find internal resistance. Okay, in first case we used to connect a load resistance 12 ohm, then we are getting the current is this one. Now if we connect 25 ohm as external resistance, by removing this one, if we connect this resistance with the same cell, we got the current 0.25. You have to find the internal resistance of the cell which gives this particular result. Okay, now the next one. Now my dear students, we will see here the concept of charging and discharging of cell, because in NCERT 3 to 4 questions are given. Okay, so we will study the concept of charging and discharging. Here the charging and discharging of cell. Okay, when we will see a cell is charging, and when we will say a cell is discharging. If any cell is delivering current, it is discharging, and if current is supply to the battery or the current is coming to the cell, it means it is charging. Other very simple, and you can identify by the circuit also. If I'm here making a circuit, using this circuit you can say whether this one is charging or discharging. Internal resistance, here the EMF, the load resistance R. Now current is moving like this way. Whether this battery is charging or discharging? The answer is yes, it is discharging. Okay, here this battery is discharging. Now my dear student, if it is discharging, then how the current will be calculated? This current we are going to find if it is discharging. Okay, now we can write here the E is equals to IR plus IR, the very simple, and then I is E over R plus R. I hope there's no any confusion. If we talk about the terminal voltage, if it is A and B, since this is entire cell, you know, you cannot take out this particular R that is from the terminal. So this is the terminal. What will be the terminal voltage? So the terminal voltage, you will write terminal voltage, you will write it is as VAB, and it is nothing. This is the terminal voltage and it is E minus IR. Remember, in case of charging, the terminal voltage will be, in case of discharging, the terminal voltage will be E minus IR, and this is the very, very important, my dear students. Okay, so kindly note down, in case of discharging, this terminal voltage will be E minus IR. Okay, my dear student. Now the case of charging. Okay, and I am making here the circuit for the charging. Internal resistance, this is the EMF, internal resistance. To charge a cell, remember my dear student, you need to connect a heavy resistance so that the current should not be very high, because we used to charge with the high voltage. Suppose this is the positive terminal and negative terminal of applied voltage VA. This is the EMF. Now this is the point A and B across which we can get the terminal voltage. and this is the high resistance. Okay, and this is the case of charging. Charging. You will get the number of question in NCERT about this charging. Okay, in this case, remember VA is, here I'm writing VA is greater than E. Okay, this is the high voltage charging. When I will be, if this is the high potential battery, then this will be considered the mother cell of this circuit. Mother cell is the cell the cell which is responsible to the flow of current. We used to say the mother cell. So the current will start moving from here. Of course, this will not dominate in the circuit. Current will not flow from here. This will dominate in the circuit and current start flowing from here, and the current will go like this one. If current is going to the cell, it means cell is charging. Remember, if current is going to the cell, it means cell is charging. And here we can write the equation as E using Kirchhoff's law. Student, we can write here using Kirchhoff's law. If you are moving here, you get positive terminal, so the plus E, then after I R, now minus terminal, minus V applied, and then sorry, here we left I, it was the plus, no? Yes, and we are going with the current, minus terminal, so the VA, and then in the direction of current, so the plus IR is equals to 0. Now what is the terminal voltage? What will the terminal voltage over here? So the terminal voltage over here, the potential between A and B, VAB, it will be the potential, you can say, you can see here the potential E plus here IR, nothing else. So this is the terminal voltage in case of charging. This is the terminal voltage in case of charging, and this is the terminal voltage in case of discharging. That is the internal drop subtracts from the EMF in case of discharging, and internal drop sum up in case of charging. And this is the very important, you must remember, my dear student. Okay, if it is the terminal voltage, what will be the current? Could you write the current in case of charging? Yes, we can write the current in case of charging. So the current will be, from here you can find out, from this equation you can find out, the current will be VA minus, it is the EMF over R plus R. This will be the charging current. Okay, this is the charging current. Okay, genius. So we have discussed so far about the cell today, and we have studied the difference between EMF and potential difference. The potential difference and EMF, when circuit is off, then EMF will be equals to the potential difference. That is, when through the circuit current is 0, then the net potential will be the net EMF, that is the EMF will be the potential difference. Today we studied. Okay, my dear students, in next lecture we will start from the plot of terminal voltage and current to study more about the cell and battery. So we are concluding today's lecture, my dear students. Thank you very much.